So there's an arc to the learning in this class. There is, the links should be on the website. There's an arc to learning in this class. You spend the first, about third or so learning to code and learning some analysis along the way. And then by the end of that period, the coding is essentially done. And then we just reuse the same, the same techniques in more and more complex situations. And so by the end, everybody's pretty comfortable. Yeah, I'm glad you find the reference useful. One of the things I feel is a drawback of the textbook is we don't have an index. And so that's something for us to work on. Okay, 10:10, and we are going to get started. So you have, at this point, quite a lot of skill in working with tables. And it's time we started working with some real data. So today we'll work on the census, but before that, as usual, I have grief here. Okay. The announcements are just the regular schedule. Nothing's regular yet because we've kind of started. Homework is due tomorrow. Tomorrow's Thursday. As usual, you will get bonus points for submitting by tonight. Solutions have been released. Now, all of this kind of information will be on ED. This week, it's post 193. And regrade requests, likewise, you'll find information on ED. I want to add a few things. Office hours are in full swing, so you should please, everybody be aware that from 12 to 5 every weekday, if you go to 145 Moffat, you will find data aid support. And I do encourage you to make use of that, not just because you're going to go see a GSI, but because it's a chance for you to work with other students. People make friends in data aid office hours. All right, so please go. It's a lovely big room. And hopefully it will be helpful. Professor Wagner's hours and mine were posted on ED. Today is my day for one-on-ones if you're having some personal situation that is affecting your work in Data 8. And then, we have other hours as well. I might try and pop in this afternoon to 145 Moffat. Okay, so at this point, you are very used to how the class works. The people who are, I do need to address are the people who are still on the waiting list. If you are not very high on the waiting list, then it might be a good idea to look at Plan B because the waiting list is still very, very long. And I'm sorry about that. The class is offered every semester, including summer, for this reason. Okay. So goals for this week. It's a short week, so we have today and Friday. We're going to start with a quick review of tables, and then we will work with census data, not just to calculate numbers, but to make some observations about the US populations. And you'll see pretty quickly, even before we get to the census example, that we are going to want to visualize. We're going to want graphs because when you have a large set of numbers, everything kind of swims in front of you and it's just nicer to have a picture. So on Friday, we're going to talk about visualizing data, in particular distributions, which we will define on Friday. So today's goal is to do a table review and work with census data. Now, I will say that I'm going to go rather rapidly through the review. If it's too rapid, please scream on chat. Okay, thank you. So you know that a table is a sequence of labeled columns. Can I ask you something? Do you see my mouse at all? My cursor, sorry. Great. So these rows correspond to individuals. Now, individuals, the individuals can be well, they are the units on which you are measuring the attributes. The attributes are in the columns. Attributes are properties of this unit. So this is a state. The state has a code, and the state has an area, which happens to be in square miles here. All right. And so the individuals are in the rows, the columns are the attributes. The columns, because each column represents one attribute, you can represent it by the same data type. And so the columns are arrays. Okay, so now to work with tables, you know several methods. First, you got to make them. So there's a read table that you have seen many times, where you can read data in from a CSV or other table formats. And then once you have, or you can create one yourself by starting with an empty table that is table with no argument. That's an empty table. And then you can do with columns. Now I'm going to say something. There's with column and there's with columns. With column is when you are adding just one column. With columns is when you're adding one or more. Let me just tell you, I always use with columns because I can't be bothered to see whether there's an S or not. I'm actually curious about your view. Should we have both methods? In the library, it's our library. We can do whatever we want. Not necessary? No? Yeah, okay. So I will pass this. With columns works fine. Yeah, I think so too. I'll pass the feedback on. Thank you. I really appreciate that. Okay, so you create a table and then you need to know, oh dear, it shouldn't be doing that. With one column, it should be okay. There's probably some other issue that's going on. Okay, so you need to know how big the table are, how big the table is. And so num rows and num columns count the number of rows and the number of columns. You can refer to columns by their labels, which are strings or indices. So column number 0, 1, 2, 3, 4, etc. Okay, indices start at 0. This is a very Python thing. Okay, so to access data in the column, this is crucial. Dot column gives you back an array. Now, why is that important? Because the attribute in a column is something you're going to want to do arithmetic on, right? Possibly you're going to want to combine multiple columns, all right? So when you want to do arithmetic, you need, well, basically a list of numbers, and that's what dot column gives you. It doesn't give you back a table, unlike methods like select and drop that create a new table. Okay, so if you want to do something like I need the sum of something or I need the max of something, you're looking for an array, and dot column is your friend. Okay, thus far, anything seem unfamiliar? All good? Okay, so now we want to look at the individuals, and sometimes we want to separate out the individuals into groups, want to look at one group rather than the other group. So sorting is a natural thing to do. You can sort the rows in increasing order of the column by default. If you want a decreasing order, then you need the argument descending equals true. For the with columns function, does the data have to be an array? An array is good. A list will also work. But we will always be using arrays. Yes, the data have to be presented as an array. So your arguments are the label of the column and the array that contains the content of the column. Okay, so you can sort, and this is very useful to see roughly how your attribute behaves. Okay, so now sometimes we want to select subsets of individuals. Take gives you back a table. Take is used in very specific circumstances when you know exactly which index you need, which rows you need. You already know, right? I need rows 3, 8, and 10. Then you make an array, make array 3, 8, and 10, and then you can use take with that, but typically we want, I want all the individuals, I want all the states whose area was bigger than such and such. Well, in that case, you use where, right? So where has to go through each row and see is the condition met or not. And then it just gives you back the rows where the conditions are met as a table. Perhaps the most common use of where is when you're looking to, where the individual is a student. So, where there's one particular property. So R equal to is very common. And because it's so common, it has a shorter form. If you go table.where column label and just value without the R, it's assuming that you're looking for equality there. Okay, are we ready for a demo, or are there questions about this? Okay, you guys say nothing, I keep moving. Okay, so here's our trusty notebook. I will run my import cell, do not forget that. Okay, so we're going to do our demo on the welcome survey that you guys filled out, I think last week. And so here are the data. Now you filled out many, many, many more variables. Thank you very much. We have restricted to 7 of them, which is which year are you in, your extroversion score, the number of people you text, how many hours you sleep. I was very impressed, by the way. I was very impressed. Somebody said that they sleep for like 7.25 hours on average. That's a very precise estimation of how much you sleep. I have to tell you that when I'm going to bed, I'm so tired that I have no idea what time it is. So I could not answer this question. All right. And we have kept only the rows, only the data where the student filled out all of these. Right, so we've left out the people who didn't respond. Okay, so I looked at that and I just had to find number of textees. The question was, on average, on a typical day or on average, how many different people do you text in a day? Not how many texts do you send, but how many different people do you text in a day? And I needed to find out the largest one of that. Okay, so now I'm doing the largest. So no doubt, I'm going to want a maximum of the number of textees. And somebody please tell me, what method should I use? I'm trying to do an arithmetic operation. Exactly. That is why, because it's an arithmetic operation, I should use dot column. And the maximum number is 100. There's a person or persons in this class who texts 100 distinct people every day. So now this is a research university. We have to look further into this, right? I mean, we can't just let this go. So okay, are we ready? You want to find out who these people are? This would be amazing. Okay, so woohoo! We have a second-year student who gives themselves an extroversion score of 10 and says that they text 100 distinct people every day. They have a good amount of sleep. I don't know how with all that texting, but they have a good amount of sleep and they're right-handed in pretty much everything. Now, I have to tell you, I was going to tell all of you, please find the student, but I don't have to, because this student is going to find you. And I think by the end of data 8, this 100 might rise to 1500. I'm not sure. Anyway, whoever you are, if this is an accurate reflection of your personality, thank you so much, because we need to be in touch with each other. So I really appreciate this. More power to you. All right. So you're supposed to get 8 hours of sleep. All right. So how many students get 8 hours of sleep? Now, first, I need to identify who are the students that get at least 8 hours of sleep, and I do that with a where. But I don't want the whole table, I just need to know how many students, so I count the number of individuals in this table, that is the number of rows. And okay, I'm going to tell you, only 400 of you roughly are sleeping at least 8 hours a week. If I had been filling out the survey, I would be not in this group, just like the majority. We should all probably sleep some more, but this group is very healthy and they have a good balance, so congratulations. Okay, thus far, is the review kind of okay? Things making sense? All right, let's go. Wonderful. Okay, so if I want the average number of hours of sleep, then I actually can't remember if you used this method in your lab. Have you used np.average yet? Wonderful. So you know that NP, you can calculate the average, and now you know that average is an arithmetic operation, so I need an array to work on. And so I will use dot column just as before, and your average hours of sleep across all students is about 7, which is pretty good. We've imported NumPy at the top cell, yes. And we imported it as NP, that's the NP there. Okay, so on average, you're spending 7 hours a day sleeping, and I was interested in whether the different sleep positions have any bearing on the number of hours slept. So, okay, on average, how long do side sleepers sleep? Well, okay, so first we have to identify the side sleepers, which is I have to do a where sleep position. And now I have to figure out what I am going to put as the condition, because the side sleepers include those who sleep on the left and those who sleep on the right. And so I go here and I see the sleep position was on your right side. Now I'm thinking like a computer, okay? The other one is on your left side, right? So the words that are common to both are on your and side. Agreed? All right, terrific. So I could look for on or your, but then I would also get the people where it says, you know, on your front, on your back. I don't want that. Side is the one that is unique to this. So I to this pair. So I am going to do, I'm going to try this. Okay, I'm going to say where the sleep position are containing means contains that particular string. SID, and I'm very careful there. It's lowercase because that's how the that's how it appears in the text here. And then we do an average of that. And look, the side sleepers have almost exactly the same average as the overall group. So the position doesn't seem to make any big difference. And I just wanted to make sure that the side sleepers were not somehow very unusual or the bulk of the group. I just wanted to see roughly what proportion were side sleepers. So I already have a table of side sleepers. Can somebody tell me what I have to do to get the proportion? First, I have to count them. How do I count them? Yep. That's the number. And then how do I get a proportion? Proportion, yes, exactly. I don't need len because I've already done divide by what now? Total number, how do I find that? Yeah, very good. Do the same thing, but on the big table. And so it's about 57% are side sleepers. It's not a tremendous majority. So you guys are sleeping around 7 hours. Okay, so let's see. Oh, I wanted to show you something. Today we're going to, read in a table of data, and it's, somebody else created that table, and sometimes the column labels are a little longer than you need, especially if you are restricting to just a few columns and there's some context where you don't need the entire long column labels. So notice here that in our table, we have hours of sleep, sleep position. And that is because we can't just have position because it's not clear. We have so many variables here. So that's why hours of sleep and sleep position. But if you restrict to just the two sleep related columns, then you kind of know this is about sleep. And so you may want to reduce the size, the length of these strings. So relabeled does that. We're switching the label hours of sleep to hours and sleep position to position. And so then you get a 2-column table with the smaller and more usable column labels. But even here, you notice that we had to retype in these strings. Is there a way out? Can we be even lazier? We can refer to columns by their, we can refer to columns by their labels, but also by their index. And so you can do the same thing. You select your hours of sleep and sleep position columns. And then, okay, when you create this table, 2-column new, it will have one column called hours of sleep and a second column called sleep position. What's the index of the hours of sleep column? 0. That's the first one. And what's the index of the position column? 1. Thank you. And if you do this, this is shorter to type and you get the same table. Okay. Questions? All right, so let's just quickly make sure that we're all okay. Well, how about we have a discussion question now? And just post on chat. So okay, so this is a table you're familiar with. The NBA table has columns player, position, and salary. And you are asked to create an array containing the names of all the point guards who made more than $15 million. The salary is in millions of dollars. Okay, so you look at that, and what are you asked to provide as your answer? What is the type you are asked to provide as your answer? An array. So what are you thinking here? What are you going to need? You're going to need dot column somehow. All right. So can somebody suggest, so if you go back through this, you basically plan your code. You're going to need a dot column, right? And you're going to have to apply dot column to the column. What column? Which column? Yeah, salary column, right? And now, but not for the entire table. So who do you have to restrict to? PGs and salary more than 15 million. Exactly. So can somebody it's a very good idea to be able to say in English how you are going to do this code. Can somebody suggest what you're going to do? Are above or equal to, it says more than 15 million. How about just doing are above? Yeah, so we need a where we have R above 15. We need where the position is PG. Okay, so let's see. Is this making sense? You could have done R containing. I don't think there's any other position that includes PG. All right, so the point is not so much that there is anything particular about this example. The point is how you put together your code. Okay, yeah, sure. You could string together a bunch of wheres. We use multiple lines just because the code then is much more readable. And it's also much easier to, here's a question. Can we use dot select instead of dot column? What would be the problem with using dot select? It would give you a table, but the question asks for an array. All right, so if you have multiple lines, you set up interim tables, then not only is your code more comprehensible, it is much easier to debug, right? You just look one step at a time instead of writing a very long line of code. Okay. Okay, so here's a quick question. I'm going to give you two expressions. We're going to start with the original NBA table. I'm going to give you two expressions, and you have to tell me what is going to be the answer. Okay, we're going to enter those two lines of code in a cell. What are we going to get as the answer? And I'm going to give you two, well, the only possible choices are 0, 1, 2, and 3. Okay, so lots of people are saying 3, why not 2? I've dropped 1. I didn't reassign. I didn't reassign the table. I have not redone NBA. The first one says NBA.drop position. I see that table, but it's not assigned to anything. It's definitely not assigned to NBA. All right, so NBA is unchanged. So when I do NBA.num columns, I still get 3. And this is something very common that you have to make sure that when you are writing your own code, that you keep track of. Let's actually run these things. Okay, so NBA, I'm reading the table, and NBA has the columns that were advertised. And so this is the code that we said we would run to get, look, an array of these players who made more than 15 million that year. And question B was, if I take NBA and drop the position column, and then I ask for the number of columns in NBA, then I still get the original number of columns in NBA because I didn't reassign NBA to the smaller table. All right. So armed with this information, let us work on a big data set that we get from an outside source. And so we're going to talk about the census. The census happens every 10 years, and the Census Bureau counts how many people there are in the United States. They don't have to be citizens, right? They just have to be people in the United States. Okay, and in the interim years, it also does some surveying, and it estimates the populations in the interim years. Sometimes it improves upon its estimate of the census count in the census years as well. Okay, so why do we do a census? Why? I mean, because it's a massive operation. It's not an easy thing to do. Why are we counting everybody? House of Representatives, exactly. It's required by law. This is how the congressional seats and also federal funds, how taxes shall be apportioned to the states, is according to their respective numbers. And this becomes very, very important. Okay, so the census has to be done carefully, and it is not an easy thing to do. Now, we'll look at the data in a moment, but a census table, as you can imagine, is a very complicated thing. We're looking at a particular one, and you have a reference to its description at the bottom there. So values have column-dependent interpretations. This is true of every table, right? The value 2 in one column does not have the same interpretation as the value 2 in another column. It depends on what the column is standing for. Okay, so immediately there's the issue of some variables are not numerical, but we assign numerical codes to them. Sometimes it's easier to represent categories by numbers, but then choices are made about what the categories are, and there we go. For each individual, we are required to select one of exactly two options for the sex of that individual. And immediately you can see just providing these categories and no others can cause difficulties in interpretation and in accuracy. So we'll talk a lot more about this column in a little bit. So there is, look at that long column name, POP estimate 2010 column is the July 2010 estimate. And then we have 2010 and then all the way up to 2019. Okay, and then there are some aggregates. All right, so the sex code 0 is the total of the male and female rows. The age 999 is now nobody's 999 years old. It's the total of everybody in every age group. The ages are in single years, so 0, 1, 2, 3, 4 completed years. You don't have to remember all this. We'll show you in a table, but you're just getting the sense that somebody has decided in the table first how to gather the data and also how to represent the data. We use numeric codes because they take up less space. Okay, so if I look at the values in a column, they are arrays, so they are the same numerical type, but from the point of view of data analysis, one number is not exactly like another. All right, age 12 means 12 completed years. Age 999 means that we are adding everybody in all the ages, and that as a data analyst, you have to be conscious of this. And so if we look at these data, then we can discover some interesting features. And let me just take a couple of questions if you have them, and if not, we'll go on to a demo. All right, one of the things I'm going to tell you is that we give you the original source data as much as possible. And so we will go directly to the census and pull their data set. Now, okay, so this is a table with 306 rows. We'll discuss in a minute where the 306 rows is coming from, and a whole bunch of columns. You see there's a sex code, there's age, and then there is the census value of the population, and then there is the estimates made, and then there are the estimates made in the in-between years. Now, we are not going to look at all of those columns. We are just going to restrict to the sex column, the age column, the 2014 and 2019 columns. Okay, so that table we are going to call partial. It's a table, and I will select the columns. And so now this is a much more manageable thing. Still 306 rows. I've just reduced the number of columns. And so I want to relabel, these are sort of awful. Well, they're just clunky. So I want to call this one 2014 and this one 2019. Can somebody tell me what index I should put here? The 2014 column, yes, 0, 1, it's number 2, and that one is number 3. Okay, so what we're doing now, this is called data cleaning. Right, we have decided what we want to look at, and then we just sort of clean up our table so that it is convenient to work with. Yes, you can definitely put the labels instead of the indices. Okay, so let's take a look at some of the more unusual ages. So I'm going to look at the ages that are at least 100, and then I'm going to sort by the age column. Okay, and so I want you to look here. First, let's look at the 999, right? Somebody remind me, this 0 stands for what? The 0 in that 999 row, it's the total of males and females. Okay, so this number, this 328 million roughly, is the sum of these two. All right, and so this 328 million, that is the population estimate in the US in 2019. Correspondingly, the population estimate in 2014 was 318 million. You can see that the population has grown. Okay, now I want you to look at age 100. So you have the same feature that the 0 row is the sum of the 1 and 2 rows. But there is something particular about the age 100 column that we did that was not in the census called that 100 plus. We've labeled it 100, but you have to remember that 100 means aged 100 and above. So the 100 age category has a different status than age category 0, 1, 2, 3, 4. Those are individual years. 100 is multiple years. Okay? Questions? Right. So what I'd like to do now is look at sex ratios in the United States population in 2019 only. So I'm going to drop 2014. And 100 means, okay, in the original data set, the label was 100 plus. It was a string. We made it a number, but then we have the caveat that that 100 means 100 and above. Does that answer your question? Wonderful. Okay, so I'm restricting to the 2019 population. And I'm looking at the ages. And, you know, at this point, we really should look at that code. Okay, so sex has been coded as in the same way since the census started in 1790. Essentially, the code has always been binary. So the 2020 the census, recent censuses have male is code 1 and female is code 2. But since 1790, there is a lot of research about whether human biology is much more complex than just this simple binary categorization. The question requires you to select exactly one of these. Okay. And by doing so, it somehow fails to reflect the fact that sex categorization is more complex. Now, what we're discussing here is a particular instance of something that is broader. When you, as a data collector, decide on the categories that you are going to offer in your survey, you are already making some decisions there. And already there, you can introduce bias before you've taken any data. And so that is something for us to be aware of. Now, these data have been already taken, and so we have to work with them. We have to remember, though, that by using the historical form of this question, you can simply exclude some people. Some people will just not know, well, I cannot answer this question because this question does not reflect me. We'll get non-response. That's a bias. And some people will feel, well, I don't fit. However, I am legally required to fill out the census form. So what the heck, I'll just fill out something. You will get inaccurate responses. That's a different kind of bias. And now, what is the census for? After all, yes, it is for apportionment, right? Congressional seats and taxes, but census data are also used to make policy. And if your question biases the responses, then it becomes very hard to use the data appropriately. So when we design surveys, have to think about our own biases and our own state of knowledge before we create categories, before we put human beings into boxes. So let me ask you something. Recently, there has been, in the past month or two, there has been a discussion about the 2020 census, and it's the change in the code reflecting some other attribute. Does anybody know, has anybody read anything about a change in a census question? Anybody? Not citizenship. No, it's not the citizenship question was, race. Exactly, ethnicity. Race and ethnicity. Previously, in earlier censuses, the race/ethnicity question, those two are different things, used to require people to pick exactly one. They have changed it. They have changed it. It used to require people to pick exactly one of a bunch of categories. Now, there's a lot of people in the United States who don't feel that they are exactly one of a bunch of racial categories. We are a very rich and complex society. So now, ethnicity and race have been separated, and you are allowed to enter multiple, you are allowed to select multiple categories. So that gives you a more accurate reflection of how people identify, and that allows you to choose as the policymaker to make better policies, because you have a better sense of who the people are in your community. Now, recently there was quite a lot of discussion of US demographics are changing, and we've given you a link to one of those articles. Yes, US demographics are changing, but it's also true that the census itself changed its question, and therefore possibly it got a more accurate reflection of the demographics just by doing that. Right? It's not necessarily that the people are changing, but they are giving different and better answers. So the census does change. And in fact, there was quite a lot before the 2020 census. I think something like about 75 people, lawmakers, asked the census to address this sex question. And in the 2020 census, it was decided that they were not going to change it, but we can hope that for the next one, it will be something that will give us more accurate data. We will use the census data, keeping these caveats in mind. So we will use the word male to represent any individual for whom sex code 1 was selected, and female to represent anybody for whom sex code 2 was selected. Right, but this is the census that is the same form for all the United States. It's not a state-based form, right? And so the decisions that the states make, the decisions that certain groups make, they influence the census, and eventually the census form, we hope, will be affected. Okay, so let us go back. All right. Okay, so what we've done is we've just restricted our table to 2019. And supposing we wanted to look at all ages. Yes, exactly, I agree with you. There is progress. The progress sometimes seems very slow, but there is progress. And the progress is due to the efforts of many communities, some through great struggle. So we are hopeful, though it seems like it takes forever. Okay, so if I want to not have all of this detail, right, age 0, age 1, and I just want the data for all the ages combined, what should I put in here? Where age are equal to what? Yeah, 999, thank you. Okay, so here you have your 328 million in 2019, which is the sum of the males and the females. Which is more, males or females? Females are more. Overall, more females than males. Let's take a look at the infants. Okay, and by infant, I am going to simply define that to mean somebody who has a 999 totals all the ages, yes. That is what that code means in age. I'm going to define infants to be all those who have not finished their not had their first birthday. So age is still equal to 0. These little ones, okay. Which are more, males or females? Males. So among infants, the males are more. But overall in the population, the females are more. Something happens in the intervening years. By the way, the fact that the males are more is true of many populations. The percentage male is about 51%, and it's not actually very well understood why it's 51%, but it seems to be pretty constant. Okay, so what we are going to do is we are going to look to see at what age group, is there an age group at which you see a sort of change in more women than men, right? So for this, we are going to create 2 tables. We're going to create a table of only the females. By the way, I should not refer to females and men and women. I'm going to refer to them by their census codes, which is females and males. So I'm going to look at the female population at the ages 0, 1, 2, 3, 4, up to 99 and 100, knowing that 100 means something different than the individual years. So the sex code is 2. And now I actually want the individual ages. I don't want the 999. And so I will look at that. And you can see that the sex code is all 2. There are 101 rows. Everybody agree? And why is that good news? That is good news because I have a table corresponding to 0, 1, 2, 3, 4, up to 100. That should be 101 rows. Okay, we do the same thing for the males. Okay, now these two, the females table and the males table, are distinct tables. However, they are linked. They are linked by the fact that both reflect the year 2019. And each row, there's a correspondence. Row 0 for the females table is the female infants in 2019. Row 0 for the males is the male infants in 2019. And so these 2 columns, the 2 2019 columns, are connected to each other by the same age year. Do you agree or disagree? Are there questions? This column, the 2019 females column and the 2019 males column, is they are linked, and so we can actually look at ratios. So we will look at the sex ratio. Okay, somebody tell me, is that the right thing to do? No? Okay, what should I do? Males column 1. Okay, so male column 0. I am looking at the ratio of females to males in each year, right? So I want this count divided by this count. So 184 something divided by 193 something. I'm just looking 1 year at a time, 1 age at a time. Everyone's decided that that's wrong. Yeah, basically I want, okay, so let's actually, I want the ratio, the corresponding ratios, this female number by this corresponding male number, this female number by the corresponding male number. I'm just going to show you what the ratios columns looks like. Yeah, for every age group, I get a ratio. I'm doing it 1 year at a time. So for the infants aged 0, 95%, 95 out of every 100 were the ratio is 95. So there are 95 females to every 100 males. At age, what is it? At age 9, there are 96 females to every 100 males. Okay? So at the younger ages, we have more of which? Males or females? At the younger ages? Males. Let's look what happens. Same table, we're going to look at what happens when we have the older ages. Look at that. At the older ages, who do you have? More females. And here we are. It is a great idea to draw a line plot. Now my entire lecture on Friday is going to be line plots. Let's take a look. That is what happens to the ratios. Senior citizens, this is 65 and up, right? There is a tremendous change. All right, we're at 11. I will try to finish on time. The rest of the notebook has optional things. If you are interested, you can look. We are not going to ask you to learn this. And so it's entirely up to you. Up to this point, you do have to understand stuff. And I will see you on Friday. Thank you very, very much. I appreciate it.